So in a previous lesson, we covered the idea that if you want to find the area under a given function, like for instance, suppose we've got, this function y equals f of x, and you want to find the area between x equals a, that's an a, and x equals b. If you want to find this area between that and the x-axis, do is the integral from a to b of f of x dx. And that's all well and good as long as you only want to find the area between your function and the x-axis. But the question we're tackling today is effectively what happens if I've got some function up here, say f of x, and then some other function down here, say g of x, and this time I want to find the area between, let's say, this point of intersection, c, and this line over here, x equals d. Right? The lesson today is about how do I find the area of the region that's in between f and g, that region there. And very briefly to start the lesson, the answer is that we do the integral of the top function minus the bottom function, dx. And so specifically in this example, we notice that the f function is on top, the g function is on the bottom, and so we're going to have the integral from c to d of the top function, which was f of x, minus the bottom function, which is g of x. And in just a minute I'm going to get to an example of that, but I did briefly want to cover why that is. And this won't take long, but I want to cover why it is that makes sense. So I'm going to sort of redraw the example that I just did. We had this idea that f of x was here, and g of x was, roughly this thing here. And I wanted the area between c and d. And the point I want to make to you is, think about what we learned yesterday. We learned yesterday that if I take the integral from c to d of f of x dx, what does that give me, right? That's effectively going to give me this red area, the area under the f function between c and d. Now, if I were to go back and also do the integral from c to d of g of x dx, what would that give me? Well, that would give me between c and d the area under the g function, right? But now think about it. How could I find out what this area between the functions is? Well, it should make sense that I could take the red area, which was the entire thing, and subtract off the orange area, which was just the section under the g function, and that would give me that sort of green outlined area that's in between, right? So what we've effectively noticed is that this green area between f and g that we want is really just the integral from c to d of f of x dx minus the integral from c to d of g of x dx. But because these integrals are both with respect to x and are both going from c to d, I can just smash them together and get this combined integral. And the idea is every time you want the area between two functions, you just do the top function minus the bottom function. It does not matter if one of them is below the x-axis. And I'll cover this sometime later in a specific example. But if you've got an f function that's up here, and you've got a g function that's down here, and somebody wants the area between a and b, like if you want, I'm really impressed with those vertical lines, and I want this area in between here, it doesn't matter that g is below the x-axis. We just do the integral from a to b of the f function minus the g function dx. So that's the basic idea behind the whole lesson today. So on the next page we're going to look at a specific example of this. So here we go. I want us to find the area of this green shaded region between the functions y equals 2 to the x plus 1 and y equals x squared. In this specific example, I was sort of trying to make it clear that we sort of already know what the bounds are. Just from looking at this picture, it seems pretty clear that the left side of this region is at 0, And the right side of this region, it may be kind of unclear. I mean, my shading seems to stop here, but it seems like that point of intersection up there is probably at 3. And you could confirm that, by the way, by plugging in 3 to both of your functions. If you think about plugging in 3 here, you're going to end up with y equals 2 cubed, which is 8 plus 1, which is 9. Over here, you'll end up with y equals 3 squared, which is 9. So sure enough, that point of intersection right there really is the point 3 comma 9, which means my integral, I mean like finding that region, will be the integral from 0 to 3. Now of what? I'm supposed to do the top function minus the bottom function. Well, clearly the top function here is the exponential function. That's this one. So that's 2 to the x plus 1 minus. Now the bottom function is clearly this parabola function, which is our x squared function. So minus x squared dx. Right? And there it is. That's our integral expression for the area. Now we just need to go through and find this area. I'd recommend you pause the video here. This is a fairly simple integral. The 2 to the x is I don't know, slightly harder. Work through it. See if you've got an answer, and then you can check it against what I get. Okay, so taking this integral, the antiderivative of 2 to the x is 1 over natural log 2 times 2 to the x, plus the antiderivative of 1 is x, minus the antiderivative of x squared is 1/3 x cubed, which we evaluate between 0 and 3. So first I'll plug in 3. I get 1 over natural log 2 times 2 to the 3rd power, which is 8, plus 3 minus, and when I plug in 3 here, one of them will cancel out, and I'll basically just be left with 9, minus. Now, careful not to fall into the trap here. It's really common to feel like, oh, when I plug in 0, these are all just going to disappear. I'll agree that plugging in 0 here will make it vanish, and 0 here will make it vanish, but when you plug in 0 here, you're going to get 2 to the 0, which is 1, so you're actually going to have something here, 1 over ln 2. And so what we end up with here is basically 8 over ln 2 minus 6 minus 1 over ln 2. And so it seems like our final answer is going to be 7 over ln 2 minus 6. And that should be the area of this green region that was found up above. So the big point I want to make here is just this was just an example of me doing the integral of top minus bottom. When you're looking for the area between two functions, it's really no more difficult than that. I've got one more different kind of example on the next slide, so we'll take a look at that, and that'll be it. So in this example, we're doing things the other way around. Rather than giving you the graph and asking you to find the area, this time I'm giving you the integral and making sure that you can interpret that to go back and figure out what region that's talking about. So this question is asking you to draw a graph and shade the region whose area is given by this thing, right? So just by looking at this, we can tell that, the region is going to start at -1 and stop at 2, right? We should also be able to tell that this thing is going to be our top function, and this thing is going to be our bottom function, right? We know that this thing is supposed to be top minus bottom, and so since there's a minus in between, it makes sense that that's what it would be, right? So at this point, it's really just kind of a matter of graphing these things. And a part of this comes down to sort of knowing your functions. So, y equals x squared is a parabola. You've got 0, 0, 1, 1, 2, 4, and, backward you've got similar points here. So you've got, here's your parabola. I already missed that point, so we know we're not being super accurate. For the bottom function, I'm looking at x minus 3, so down 3, and from there a slope of 1. So you're looking at a line roughly like this. And we're supposed to find the area between -1 and 2. Alright, well, -1 is here, so that's this. 2 is over here. And so the region that we're looking at is this. right? Fantastic. Just because that area was below the axis doesn't really mean anything. It's not significant. It doesn't change the way that this works. If you were to work this integral out and get a number for it, that number would represent the area of this green region that we just drew. Not a big deal. That's all that I have for this first intro video. I will see you in the next one.